What was it again? How long would it take to go from Earth to Mars if you traveled at the speed of light?
What was that?
I think it was 300,000 kilometers per second. Or was it million?
Awesome.
I'm getting a headache.
I'm getting a stomach ache.
Let's go. We need some smart food.
Yeah.
Have you ever had a problem like this, where it's so overwhelming your head hurts just thinking about it?
About 20 times a day.
And when the numbers are so big, you can't even hold them in your head.
Oh, when I think of that money I owe my dirt bike.
Well, one way to handle large numbers is to simplify them.
It's true. Simplifying the numbers allows you to see more clearly what the problem is.
What computations need to be done without being overwhelmed by the numbers involved.
I wonder if they would have the same problem if instead of Earth and Mars, it was the distance between their two houses.
Right. If Sam lived 3 kilometers from the store, and Tree lived 6 kilometers from the store, how long would it take Mike to ride his bike between their houses if he pedaled at 3 kilometers per hour? Can you figure that one out?
Of course. Well, I would take the 3 kilometers and subtract it from the 6 kilometers. And this would leave me with 3 kilometers in between the two houses, which obviously means it was only 1 hour traveling time. But those are simple numbers.
Well, that's the idea. But you see, it's the same problem that the boys are having, except it's simpler numbers.
All right, where do we start?
Well, the distance between the sun and the Earth is 150 million kilometers. Yeah, and the distance between the sun and Mars is 228 million kilometers.
Wow.
Don't say wow.
Why not?
It makes the numbers seem too big.
But they are big.
Okay, but if we could pretend they aren't so big, maybe it would be easier.
That's it.
What's it?
Make them smaller.
How?
Well, think of the distance between the sun and the Earth. But not as 150 million kilometers, just as 150. Then we might be able to figure out what we're doing with them.
Okay, so, make 228 million kilometers 228 kilometers.
Then what?
Well, just add 150 and 228.
No, you don't add. You subtract. Huh? Look. See the cat? Now say this is the sun. Okay? This is the Earth. And this is Mars. Now it's 150 kilometers from this to this, and 228 from this to this. So what is it between these two?
Well, we already know the whole distance, and we're trying to find out the distance between these two. So you would subtract 228 minus
150. 78 kilometers.
Right, but the question was in millions.
So, the distance between the Earth and Mars is 78 million kilometers.
Wow.
Dealing with large numbers can be overwhelming.
Until you learn to simplify them.
And a man who deals with large numbers every day in his work is Ivan Semeniuk, an astronomy researcher at the Ontario Science Centre.
There are billions and billions of galaxies, each containing billions of stars, and the distance between those stars would take light many times a human lifetime to get from one point to the other. As an astronomy researcher, I find myself dealing with large numbers every day. Astronomy is so full of large numbers simply because space is so vast. Imagine we could bring the sun, the Earth, and all the planets into this room. Now, the average distance between the sun and the Earth is 150 million kilometers. But if we could shrink that down to, say, only 15 centimeters, that's only about the size of a hand span. Here's the sun, here's the Earth, only 15 centimeters apart. And here's a question I like to ask. We bring all the rest of the solar system in so it matches the size. We'll take the furthest planet away, that's the planet Pluto, and I'd like to ask, and I'll ask you, how far away do you think Pluto would have to be to fit in with this model? Now, you might think it would be, say, a meter away or 2 meters away, or even a little bit further than that. But it turns out that even at this scale, to put Pluto in the right spot, not only would it have to be, at the end of the room, it would be through the wall, down a hallway. I would have to have a pretty good arm to actually throw this thing as far away as Pluto really is, even if we only make the Sun and the Earth 15 centimeters apart. Space is enormous. But what we can do is play around with the distances. We can make them smaller in our imagination.
Why bowling? Why couldn't it be basketball or something that I'm good at? I hate bowling.
That's what was voted on.
Okay, let's get this thing done. Every kid in the class is supposed to bowl against every other kid.
So, how many games will we play?
About 20 games.
How'd you get that?
Well, there's 20 kids in the class.
Yeah, so?
Probably 20 games.
Wait, there's 20 kids in the class, and each would play the other, so that's 19 games each.
That's it. 19 games apiece. There's 20 kids in the class, so we'll each play 20 times 19. What does that sound?
That's, 380. 380 games.
But that's not right. Look, I'll show you. See? If the three of us were playing each other, I would play Sam and Mike. Sam would play Mike and me, but we've already counted that one. And then Mike would play me, which we've already counted, and Sam, which we've already counted.
So we'd only play 3 games, not 6. So how does that help us with the other 20 kids in the tournament?
Well, let's try it with 4. Suppose Billy was here as well. So I play Sam and Mike and Billy. That's 3. Then Sam plays Mike and Billy. But not me, because we've already counted that one. So that's 2. And then Mike plays Billy, but not Sam or me, because we've already counted those games. That's 1.
And we don't count Billy, because all his games have already been counted. So we just count the number of games. 3 plus 2 plus 1 plus 0, 6 games.
Yeah, I think we've got something here. So for 3 players, it would be 2 plus 1 plus 0. And for 4 players, it would be 3 plus 2 plus 1 plus 0.
Yeah, if we had 5 players, it would be 4 plus 3 plus 2 plus 1 plus 0. It's a system, a pattern.
With 20 like we have, it's 19 plus 8 plus